So in this video today, we're going to talk about the interior and exterior angles of a triangle. So we are going to, by the end of this lesson, be able to answer the question, how do we solve angles for triangles in the interior and exterior? So the first thing I want to talk to you guys about are some terms, okay? So this first term is an auxiliary line. This is a line that we draw so that we can use it in a proof. A corollary is a theorem whose proof follows directly from another theorem. We're going to talk about one of these today. And the auxiliary line. So interior is obviously a set of points inside the line or the shape. Exteriors outside the line or the shape. Interior angle is an angle formed by two sides of a polygon with a common vertex. So it's an angle inside, okay? And then exterior angle, same thing, outside of the polygon. Remote interior angle is an interior angle of a polygon that's not adjacent to the exterior angle. So we're going to talk about what all these mean in just a minute in the lesson, okay? So first of all, I want to talk to you all about the proof of the triangle sum theorem, because then we're going to use this. So it says, given ABC, triangle ABC, that's this triangle up here, prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. So the first thing we're going to do is construct an auxiliary line parallel to AC through B, okay? So we are given, don't know why that's written like that, but we're given the auxiliary line, okay, and that AC, notice AC right here, is parallel to BD, okay? Then we're going to talk about the straight angles, the angles of a straight angle. Sorry, y'all. So wouldn't that be 4 plus 2 plus 5? And when we add those three together, wouldn't that be equal to 180? So that's exactly what we're going to do here. We're going to add those three angles together, okay? So let me scroll up a little bit here so we have a little more room. So we're going to say that the measure of angle 4, maybe if I can write, the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is going to be equal to 180 degrees. Where did I get that? Right up there. Y'all see that? The measure of 4, the measure of 2, and the measure of 5. When I add those three together, I get 180 degrees. Then it says that the measure of angle 1 is equal to the measure of angle 4. So why would the measure of angle 1 be equal to the measure of angle 4? Okay, so let's look at this. So let's just extend this parallel line right here, okay? And I'm going to erase what I have up there so you can see it. So now we have these two parallel lines, right? And they're cut by, there's our parallel lines, and they're cut by this transversal right here, right? So why would angle 4 be congruent to angle 1? Aren't those alternate sides of the transversal and interior to the parallel lines? Yeah, so these are alternate interior angles, and that's the theorem. So that's what we're going to write there. Okay. And then if we are looking at another pair, do you see another pair of alternate interior angles? I do. So again, let's extend this line a little bit more over here and a little bit more over there. And this time let's draw this like this. Whoops, didn't do that very good. So let me do that again. So we're going to draw this transversal now, this one right there, okay? So do you notice that 3 is congruent with angle 5? And again, aren't those congruent because of alternate interior angles theorem again? So we're going to say the measure of angle 3 is equal to the measure of angle 5. Okay, so now notice that if we go back up to our original drawing up here, we're trying to figure out the angles, we're trying to prove that angle 1 plus 2 plus 3 is 180 degrees, right? Isn't that what we're trying to prove here? So how could we do that? So let's look here again. We've got the measure of angle 4 and 2 and 5. When we add those together, we get what? 180 degrees. So what are we going to do if we've got the measure of angle 2 right there, see that? In the measure of angle 3, so the measure of angle 3 is congruent to the measure of angle 5. You see that? So that means that we can substitute in the measure of angle 1. So look right here. So we're going to measure, we can do the measure of angle 1 right there. So that's where we got that from, okay? And then we could also substitute the measure of angle 3 in, right? Because of this statement right here. That is congruent with 5. So that's where we got those two measures. So what did we do? Didn't we do the substitution property? We did. So that is what happened here. And this is substitution property of equality, right? Okay? All right, now, we're now going to use the triangle sum theorem. So this is what you guys are going to have to memorize, okay? You're going to have to memorize that the angles inside a triangle always add up to be 180 degrees. So that means to find the third angle, so like example 1 here, we're going to add the two together and we're going to subtract them from 180 because all three added together should equal 180. So if I was to write this like this, I'd say the measure of angle A plus the measure of angle M plus the measure of angle T equals 180, right? Okay, so that means I've got 27 here, and then I've got 82 here, and then I've got the measure of angle T, and it's equal to 180, right? So 27 plus 82 is 109, right? And then the plus the measure of angle T is equal to 180. So when we subtract 109 from 180, so the measure of angle T is going to be equal to 71 degrees, right? Okay? So now again, remember that if we can add the two angles together, then we could subtract them from 180. So that's the complicated way to do it. Let's see if you guys can do this. You try a simpler way, okay? Go ahead and pause me, come back to me when you're done. So in this case, again, we're going to do 70 plus 40. Isn't that equal to 110? And again, we're going to do 180 minus the 110. What does that give me? 70 degrees. So that's what x is equal to, right? 70 degrees. Got it? So don't overthink this. When you add the angles inside a triangle together, they equal 180. So this time, notice that we don't have any of the measures. So once again, we're going to add all three of them together, and we're going to set them equal to 180, right? So we're going to set this up like this. 8x, minus 1, minus, oh my goodness, x minus 1 plus 3x plus 4 plus 3x plus 9, that equals 180. So we're going to combine our like terms. So notice here we have an 8x, a 3x, and a 3x, right? So isn't that going to be 8 plus 6x? So that's going to be 14x, right? And then we're going to combine our other like terms, our minus 1 and 4, that would be 3. 3 plus 9 is 12, right? So that would be 12. And that's equal to 180. So we're going to subtract the 12 from both sides. So we want to get the variable by itself. So that's going to give me 14x is equal to 180 minus 12 is 168. And then we're going to divide both sides by 14. So x is equal to what? X is equal to 12, right? Okay, now we're going to plug that 12 back in. So we want to find the measure of angle R, which is this one right here. So we're going to do 3 times 12, that's 36, plus 9 would be 45, right? So that's 45 degrees. And then we're going to do the same thing with angle T, right? So up here, we're going to go 3 times 12 plus 4. So that's 36 plus 4, that's 40, right? So there's the measure of that angle, and here's the measure of that angle, okay? All right, let's see if you guys can do the you try now. Okay, come back to me. All right, so now, again, we're going to add all three of these together, right? So we're going to say x minus 10 plus 2x plus 5 plus 35, and all of that equals 180, right? So again, we're going to combine our like terms, our x and our 2x, so that gives us 3x. We've got 5 plus 35, that's 40 minus 10, so that's plus 30, equals 180. So again, we're going to subtract the 30 from both sides. So 3x equals 150. So x, we're going to divide both sides by 3, right? Sorry. So x is equal to what? 50, right? So x equals 50. And this time it's asking us for m and n, right? So the two angles that are left. So m is going to be 50 minus 10, which is equal to 40. So that's going to be our angle m. And then our angle n up here is going to be 2 times 50, which is 100, plus 5, so that's going to be equal to 105, right? So that's going to be our angle n. So, and the way we can double check this to make sure it's right is add 40 to 105, that's 145, plus another 35, and guess what? That's 180, okay? Good way to check it. So here's our corollaries. So our first corollary says the acute angles of a right triangle are complementary. That makes sense, right? Because here we would be doing 180 minus 90, and doesn't that equal 90? So when we do these types of problems, when there's a right angle, we can just say those two other angles, when they're added together, they equal 90, right? And then the next one is, and so this has to do with a right triangle, right? And then our next one, the one below it, says the measure of each angle of an equal angular triangle is 60 degrees. So this has to do with an equal angular triangle, right? So when it's equal angular, it means all the angles are equal. Okay, so this is an equal angular triangle. Okay, when all the angles are 60, because 60 plus 60 plus 60 is, guess what? 180. All right, so for example 3, what we're going to do is we're going to just add those two together, 2x plus 1 plus 5x plus 5. That equals 90. And the reason for that, again, is because we've already taken up 90, right? So 180 minus 90 leaves us with 90. So we're going to combine our like terms, 2x and 5x, that's 7x. We're going to add the 1 and the 5, that's 6. And that's equal to 90. So then we're going to subtract 6 from both sides. So that means 7x is equal to 84. And how many times does 7 go into 84? X equals 12, right? Okay. So now to find these angles, for this first one right here, for angle E, we're going to go 2 times 12 plus 1. That's going to be 24 plus 1, which is 25. So that's the measure of angle E right there. Then we're going to find the measure of angle F. So this time we're going to do 5 times 12, that's 60, plus 5, that is 65, right? So 65 plus 25, what is that? 5 plus 5 is 10, 6 plus 2 is 8, plus another one is 9. So right, that is my angle F right there, okay? So now, for the U-try, this time again, we have that it's a right angle. It's a right triangle, right? So this time we're going to just subtract that 41. So we're just looking for the measure of angle D, right? So we're going to go 90 minus 41. That's 49 degrees, okay? So that's 49 degrees for our angle D, okay? Now U-try 4 says the measure of one of the acute angles in a right triangle is 63.7 degrees, which is the measure of the other acute angle. So go ahead and pause the video, see if you guys can do this. Come back to me when you're done. So if it helps you to draw this, then do it, okay? So that means that we got a right angle right there, right? And then one of these is 63.7, and we're trying to find that one, right? So isn't that what we just did? So we're just going to go 90 minus 63.7, and that's going to be 26.3, okay? All right, so our next one is the isosceles triangle theorem. So in any isosceles triangle, the angles opposite the congruent sides are also congruent. So that means, look here, these tick marks, these two dashes up here tell us that AC and BC are congruent, okay? And that means that these angles down here, angle A and angle B, are congruent. Okay, the altitude bisects the vertex, angle C, and the altitude CM also bisects the base of AB. So when we talk about this, what we're going to do is we're going to use the properties we just talked about. So we know that these two base angles right here, the 4x plus 12 and the 5x minus 3 are congruent because it shows us they're congruent. So we're going to say 4x plus 12 is equal to 5x minus 3. So we're going to subtract 4x from both sides. So now 4x is gone, and we got just x over here, and we're going to add 3 to both sides. So now our 3's are gone from over there, and that's going to be 15. So it says find x and the base angles, okay? So that means that we're going to put that 15 back in. So here we're going to say 5 times 15 minus 3. So 5 times 15 is 75. 75 minus 3 is 72 degrees, right? Now, to make sure that I got the right answer, we could put it back up here too. So 4 times 15 is 60 plus 12 is also 72 degrees. Now, could you find the last angle? You should be able to, right? Because you know that 180 degrees is equal to what? 72 plus 72 plus our y, which would be that angle right there if we had to solve it, right? So that's going to be 180 is equal to 144 plus y. So we would subtract the 180 minus 144, right? And that would give us, let's see if I can do it, 180 minus 144. So that would mean that this angle out here is what? Y is equal to 36 degrees, okay? So that's what it would be. All right, now let's do the next one. So this time it says to find, for the you try, measure of angle B and the measure of angle A. So we know that the measure of angle B is 40 degrees, right? So we would add 40 plus 40, that's 80, right? And we would do 180 minus our 80. So that means angle A is going to be 100 degrees, right? Because again, all three of those angles have to add up to be 180 degrees, okay? So the last property we're going to talk about today is that if two angles of one triangle are congruent to two angles of another triangle, notice that L is congruent with R and M is congruent with S, then obviously the third pair of angles are congruent. So let's talk about what that means. So let's just say this was, let's just say this was, let's just say it was 90 degrees, okay? That means this is 90 degrees, right? And then let's say this other one over here was 30 degrees, okay? Which means this is 30 degrees. So what does that mean the third angle is? So wouldn't it be 90 minus 30? So that would mean this one is 60 and this one is 60. So do y'all understand why this is true? Because obviously if two angles are the same in both triangles, then the third angle absolutely has to be the same. So let's look at our example 5. So for example 5, notice that angle G is congruent with angle H, right? And what else? Angle F is congruent with angle I, okay? So that means that angle K has to be congruent with angle J. Now, we actually have measures up there, so we're going to use an equal sign, okay, to solve this problem. So we're going to say 4y squared is equal to 6y squared minus 40. So these are like terms. Remember, if it's an x squared, or a y squared in this case, that they are like terms. So we're going to subtract the 6y squared from both sides. Okay, let me extend this a little more so we have a little more space to work with. Okay, so that means now those are gone, right? And we left negative 2y squared is equal to negative 40. Our next step would be to divide by negative 2, right, on both sides. So that's going to be that y squared is equal to what? Isn't that going to be 20? Okay. So if you recall, when we have the square root, or we have a y and a y squared in the 20, we're going to take the square root of both sides to solve this. So that means y is going to be equal to the square root of 20. Now I'm just going to leave this like this to solve the problem, because now it's asking us to solve for k and j. Well, truth be told, we know that they're equal, right? So we can just solve for one of them and we'll have the other one. So when we do this, we're going to do 4y squared. So 4y squared, right? So what are we going to do? We're going to put that square root in there. So we're going to do 4 square root of 20 squared. Hopefully you guys remember that when you square a square root, they cancel each other out, right? So this and that cancel each other out. So it's just going to be 4 times 20, which is what? 80 degrees. And what do you know about both these angles? You know that they are both 80 degrees, right? Because they are congruent. Okay? All right, let's see if you guys can do our last you try here. Pause the video, come back to me when you're done. So notice again that M is congruent with R because it has one arc and one arc. N is congruent with S because it has two arcs and two arcs. So what does that mean? That means that this guy up here, 1, 2, 3, and 1, 2, 3, right? We can say that P is congruent with T. So that means we can set them equal to each other again. 2x squared is equal to 4x squared minus 32, right? So this time I'm gonna subtract the 2x squared from both sides, y'all. Okay, so that's going to give me 0 over here is equal to 2x squared, minus 32. So what do you think I'm going to do next? Yep, you got it. I'm going to add 32 to both sides. So I'm going to add 32 to both sides. So now I got 32 is equal to 2x squared. What would my next step be? Divide by 2. So now we have 16 is equal to what? X squared. Now how do we solve for that? So don't we take the square root again of both sides? So we're going to take the square root of both sides. Now remember, when we take the square root of both sides, typically we would put a plus or minus in front of it, right? So this is going to be x is equal to both plus or minus 4, okay? So when we square a negative, remember that that's going to give us the same answer no matter what, okay? So when we plug either one of those back in, it's going to give us the same answer. So here again, we could plug it in right here. That's going to be the easiest place to plug it in, right? So we're going to go 2 times 4 squared, right? So isn't that going to be 2 times 16, which is equal to 32 degrees, right? So that's going to be the measure of both of these angles, right? Both. Y'all got me? Because again, not that one, sorry. Yeah, that one. No. All right, I'm having issues today, y'all. What can I say? All right, and we could double check this, right? So we could do 4 times 4 squared minus 32. So that would be 4 times 16, which is 64, minus 32. 64 minus 32 is, guess what? And again, 32 degrees. And this is a great way to check it, y'all, by checking the other angle and making sure it's the same. So the last theorem we're going over today is the exterior angles theorem, y'all. So the measure of an exterior angle of a triangle, and this out here, angle 4, y'all, is our exterior angle. It is outside the triangle, right? So it is going to be equal to the sum of the measures of the two remote interior angles, okay? So what does that mean? That means I'm going to add 1 to angle 2, okay? So when I add those two together, they're always going to equal that exterior angle. Now this is why. What do 3 and 4 form? They form a what? A straight line. Y'all see that? So they add up to be 180 degrees, right? So if I subtract 4 from 3, I'm going to get what's left is the rest of the triangle. Okay, so you're going to understand as I show you. Okay, so angle 4 is an exterior angle, and its remote interior angles are angles 1 and angles 2. Okay, so that's always going to be the case. So they're not going to be the ones right next to it that form a linear pair. They're going to be the other two angles. All right, so let me show you why this is true. So let's just say this angle right here was 50. Okay, and let's say this one was 100. So what does that leave me for angle 3? It leaves me 30 degrees, right? So then what is 30 plus what gives me 180? Because that's what 4 would have to be, right? Because that's a straight line. So notice now that these two added together equal the same as that. Okay, and that's why this is true, and it's always true. So here again, we know that this exterior angle is equal to these two angles added together. So the way we're going to do this is we're going to say 15 plus 2x plus 3, that equals our 5x minus 60. Okay, so that means the two interior remote angles, they're not the ones that form the linear pair, they add up to be equal to the exterior angle. Okay, so we're going to combine the 15 and the 3, that's going to be 18, so that's 2x plus 18 is equal to 5x minus 60, okay? So that means we're going to subtract 2x from both sides. So that gives me, over here, that's gone, right? So this gives me 3x there. And then we're going to add 60 to both sides. So that's going to give me 78. And then we're going to divide both sides by 3, aren't we? So we're going to divide both those sides by the 3. So x is going to be equal to 26. Okay? Now this problem tells me to solve for angle B up here. So we're going to plug that 26 back in. So that's going to be 2 times 26. That would be 52 plus 3. So that's going to be 55. Now what I know is when I add the 15 and the 55 together, it should give me that exterior angle, right? So 15 plus 55, isn't that going to be 70? Yeah. So that exterior angle should be 70, right? So let's do this one now. Let's see. If 5 times 26 minus 60, so 5 times 26 is 130. So that's 130 minus 60. So guess what that is? Exactly what we thought it would be, 70 degrees, okay? So again, the way we can check this is 15 plus 55, that equals 70, right? Which is what that exterior angle equals, okay? All right, let's see if you guys can do this last one. Now this one's a little different, right? Go ahead and pause the video and come back to me when you're done. So do you notice this is 90 degrees, y'all? So I'm going to go ahead and write 90 right here. Because when I add the 90 with the 2z plus 1, 90 plus 2z plus 1 is equal to 6z minus 9. So 90 plus 2z, that's supposed to be a z, y'all, is plus 1. So that's 91. So this is 2z plus 91 equals 6z minus 9. So I'm going to actually subtract the 2z from both sides. That's gone from there now. So I got 4z over here, right? Then I'm going to add 9 to both sides. So that's gone from there, and that's going to be equal to 100, right? How many times does 4 go into 100? That's 25, right? So z is equal to 25. Now, what must we do with that value? Yes, we should plug it back up in here. So this is going to be equal to 2 times 25, which is 50, plus 1. So that's 51 degrees, right? So 90 plus 51 is what we should get for the outside angle, right? So shouldn't that be 141? All right, let's see if we get that. All right, so we're going to do, for this one, 6 times 25, and that's 150, right? 150 minus 9, guess what that is? That's 141, and that's what we expected, okay?